Today it's going to be 40-1 and we're going to be taking a look at the law of sines. So you're going to solve oblique triangles using the law of sines. Now recall that every triangle has 6 parts. Remember, it has 3 sides and 3 angles. Now by definition, when we try and solve a triangle, we need to find all the unknown parts of that said triangle. So for example, if you know the lengths of 2 sides of the triangle and an angle, in order to solve the triangle, you need to know the length of the last side of the triangle and the 2 unknown angles. If you know the 2 angles and a side of the triangle, what do you need to find in order to solve the triangle? If you even need to draw it out, let's say you knew 2 angles and a side of a triangle, well, you'd need to know the other 2 sides and that last angle. Now, an oblique triangle is a triangle that has no right angles. And so this is going to be an example of an oblique triangle. This is not a right triangle. None of these angles here are going to create a 90-degree angle. And so right now, we know how to solve a right triangle, or a triangle that has that 90 degrees there. We would use SOHCAHTOA. And so now what we're going to do is we're going to learn how to be able to solve a triangle in which it does not have a right angle. Now to solve an oblique triangle, we need to know the measure of at least one side and the measure of 2 other parts. And you're going to notice that if I have a side and 2 other parts, it's going to create a series of relationships. And so now the following cases are going to be considered when solving these oblique triangles. We have 2 angles and any side, so angle, angle, side, or angle, side, angle. We could have 2 sides and an angle opposite one of them, so side, side, angle. Then we could also have 2 sides, but the angle is included in between them. And then we're going to have side, 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 which means we have 3 sides there. Now we're probably wondering, okay, why do I need to know this relationship? And the reason is this relationship informs us of what formula we want to use. Now more importantly, these here, if I have the angle, angle, side, angle, or the side, side, angle, that means I need to use the law of sines. And if I use the law of sines, I would be able to find and solve the triangle. And so I can find all the missing pieces to that. Now this one right here, we're going to talk about more tomorrow. This is the ambiguous case. Like I said, we're going to talk about that a little bit more tomorrow. Then these 2 here, this is going to be the law of cosines. And so using the law of cosines, we would be able to solve the triangles there, which we're going to talk even more into the future. Now the first 2 cases can be solved using the law of sines, like I had mentioned. The last 2 cases can be solved with the law of cosines. Now we're going to define the law of sines. It's going to be this formula here. Now there is another form of this. So I could also say sine A over A equals sine B over B, which equals sine C over C. Now this is the reciprocal, right? Why do I have both versions of this? Well, one's easier in solving for a particular piece. So this is easier when we're trying to find the side, and this is much easier when we're trying to find the angle. It's just easier having the variable on top. Now, you could just use one of them always. Just know that algebraically, when you go to solve the triangle, it's just going to be a little bit more intensive. All right, first example. Find the remaining angles and sides of the triangle if A equals 4.5, B equals 60 degrees, and C equals 10 degrees. So let's draw out the triangle. Now I understand that triangle is a little bit more fancy than maybe what you were imagining. If you just draw out some generic oblique triangle, label it ABC, and go to town from there, that's completely fine. But I need to look at this and I need to examine, well, what relationship is presented to me? And so I do have an angle, a side, and then an angle, right? It looks like it's being clumped to this side, so angle, side, angle. And so because it is angle, side, angle, I am going to use the law of sines. And so I can find this missing piece right here. It's really easy. You don't even have to use the law of sines because it's 180 degrees minus the other 2 values. And so if I do 180 degrees minus 10 minus 60, that's going to give me 110 degrees. Now I can go through, and to find B and C, I can use the law of sines. So the first ratio I'm going to do is A over sine A equals B over sine B. So I plug in the values. So we said A is 4.5. We said angle A is 110 degrees and angle B is 60 degrees. And that's all from my given information here. Now all I have to do is just use algebra and get B by itself. So if I multiply both sides by the sine of 60 degrees, that will cancel out there. And so I'll get 4.5 sine 60 over sine 110 equals B. I enter that into my calculator, and you're going to get approximately 4.15 feet. For the next one, I can do A over sine A equals C over sine C. Once again, plug in all the given information. That's still 4.5, 110, C is C, and that's going to be 10 degrees. So now getting C by itself, multiply both sides by the sine of 10. So that will cancel out. So I get 4.5 sine of 10 over sine 110. Enter that into my calculator, and I get C is approximately 0.83 feet. And so that's going to be my missing value there. So I answered the question. It said find the remaining angles and sides of the triangle. I did that, and so I am done. Now you're probably wondering, well, what if I did B over sine B equals C over sine C? Like, why wouldn't I want to do that? Now, if I plug in values, let's say this is towards the beginning, I would get B over the sine of 60 degrees equals C over the sine of 10 degrees. Now, the issue here is that I have two variables. Well, that doesn't help me. How do I get a variable by itself and say definitively B equals this? You can't. And so maybe a hint here is when we go through these, notice how I have A and angle A. And so because I do have both A and angle A, it helps. So being able to go through and do this. So just one thing to kind of like just be aware of. A, angle A. So because I have both of them, that's probably the one that I'm going to use. Next one, it says use the law of sines and solve for the triangle. So we need to draw out our triangle again and label it. So angle A is 110, angle B is 49, and B is 100 inches. So once again, I need to know what relationship this represents. And so this is going to be angle, angle, side. And so I know I'm going to use the law of sines to be able to solve it. Once again, I can find this missing angle by doing 180 degrees minus the other two. And so I'm actually going to get 21 degrees for that. And so the ratio in which I have both values here, I have both B, which is 49, and B, which is 100 inches. So I'm going to say that has to be one of the values that I use. And I can find side A by doing A over sine A equals B over sine B. Now I just need to get A by itself. So multiply both sides by the sine of 110. And so I get A equals 100 sine 10 over sine 49. Enter that into my calculator, and I do get 124.51 inches. My next one, C. So I'm going to say C over sine C equals B over sine B. And so plugging the information in, I can get C by itself by multiplying both sides by the sine of 21. So I get C equals 100 sine 21 over 49. I enter that into my calculator, and so that's going to give me 47.48 inches. Now, because it's asking me to solve the triangle, I do have to say A equals, B equals, C equals, A equals, B equals, C equals. But I'm just saving a little bit of time here. But just know that you do have to explicitly state all the values. Now for this third example here, we're going to take a look at a side-side angle. If I were to draw my ambiguous triangle, say it's A, B, C, here's 76 degrees, here's 18 inches, and here's 20 inches. And so that's going to be side-side angle. Now, if I were to set up a ratio, I would say b over sine b equals a over sine a. Because I want to solve for the angle, this angle right here is what I'm going to solve, right? I have my ratio of a. I need to find what my angle b is. Remember we said we want to do the reciprocal version where the angle is on top. So plugging in the information, now trying to get b by itself, multiply both sides by 20. Enter that in my calculator, and so I could do the sine inverse to both sides. Now if I did do the sine inverse to both sides in my calculator, it's going to give me an error. And the reason why it's going to give me an angle or error is that there's no angle whose sine is 100 or 1.078. If you remember when we were solving equations, we said that it's between -1 and +1. And so because of that, there is no triangle satisfying the given conditions. And this is an example of what that triangle would look like. It's not even a triangle. So this is the reason why we called side-side angle the ambiguous case, is because there is a chance in which our triangle isn't even actually a triangle. Okay? So just kind of be aware of that. When the side-side angle, we call that the ambiguous case because there is a chance that it's not even an actual triangle. So this does conclude our lesson. If you do have any other questions, please leave them in the comments.